Hey everybody, this is Larry. Let's get this started. Hit the like button, hit the subscribe button, and let me know what you think. How did you do? Uh, let's go. Let's get this going. Write a class stock spanner, which collects daily price codes for some stocks, and return the span of that stock's price for the current day. The span of the stock's price today is defined the maximum number of consecutive days for which the price of the stock was less than or equal to today's price. For example, if the price of a stock over the next 7 days were these numbers, then the stock span would be 1112146. Okay. Um, Maximum number of consecutive days for which the price of the stock was less than or equal to today's day. Okay. So, okay. So that means that I'm just trying to understand this problem for a second. 85 is 6 because starting from today and going backwards, it's equal less than. So it includes 1, 2, 3, 4, 5, 6. 4, this is 4 because it goes to these 4. Okay. And 60 is 1 and so forth. Okay. So the first thing that I think of is there's some sort of property that we're trying to figure out. And just trying to see if there's any. I mean, I talk about this a lot on these series on these YouTubes. The thing that I always try to find is some sort of invariant that you could keep, well, not changing as you add or remove or does something to make progress, right? So starting from the left to right, starting at 100 is always just going to be 1. When you add 80, I mean, let's think about the naive algorithm and then think about how to optimize it in a way by looking for these invariants. So price is less than or equal to 100,000. So that means that that means, oh, okay. So these are just global constraints for the test cases. Yeah, it just basically what it means is that you can't do anything n squared, meaning you can't just go, okay, 80, let's look at all the other ones and so forth, right? But as a kind of for me, trying to get the feel of things, sometimes I will walk through that, right? So 100, okay, 80, yeah, okay. So 60, not so good, right? But 70, okay, what does 70 mean? So 60, 111, because it's been decreasing. 70, what does it mean? 70 means that, well, there's 2 because, well, 1 is for itself and then 2 for 60, right? But what does that mean for the invariant, right? The question is whether do we ever need the 60, like, is there a place where, or like a number that we can get later that we need the 60, right? So looking at here, I think the answer may be no, right? Because let's say it's 60, then, well, the 70 blocks it, if you want to call it that. If you have a 70, then 60 does come into play, but you need to get 70 first. So in that sense, what my intuition is saying is that when you get a bigger number than the thing that's on top of your stack, because seems like that's the progression that we're doing, then we just merge them together. And then we keep on, my intuition from this point, generalizing a little bit, is that 70 will keep on merging to the numbers to the left until it hits 70. And then it could, I don't know, you could keep track of it with, say, just put 70 on top of the stack with 2 numbers on, or like another counter, 2 on the front. So that's when 60 comes, it's like, okay, now, well, in this case, it doesn't matter. So 60 is after under 70 again. And then 75, all you have to do is, well, pop off 60, pop off 70, and then hits 80. That's a wall. So now, because 70 holds the number 2 as a counter, this holds 1 as a counter. So that means there's 3 total add itself. So that's 40 on 75. So then your new stack is 180, 75. And also, those of you whom hear me talk about these mono stack or mono queues, you may see that pattern and that it becomes a mono queue, or what I call, the min stack, because you want to get the minimum number that's inside the stack. But But anyway, these are just names and these are just things that describe it. But what I think about, like for solving this problem, I never thought, oh, look, I just need to use this monostack or monoqueue. How I solve this problem is what you saw, where I'm like, okay, one at a time, this is how I would process it from right to left or from left to right, and then pop them back on as you kind of, for each number, we want to be able to look backwards and then merge numbers in some way. And then it so happens that now that I talk about it like that, you see the stack being monotonically decreasing because it skips over 60 and so forth, or this 60 anyway. And yeah, and I think that should be good enough because the progression. So the next thing, and I'll analyze it again afterwards to look through the code, just so that you have a better visualization. But my intuition now for the analysis is that, well, each number that we check can only be pushed on the stack once and then pop off the stack once, right? So that means that it is at worst O of n and O of 1 per number amortized, because it's O of 1 because for each element, because like I said, it can only be pop off and pushed once each. But in theory, like here, 75 could pop off a couple of times, right? Pop off another element a couple of times. So you have to add the amortization. That's how we get the amortized. Okay, cool. Let's get started at the coding. I think this should be straightforward as a result. Okay, let's just. Oh, and space would be linear, which for the same reason, right? Like you only need to store each element in the stack at most once, so that's linear space. Okay. So yeah. So let's say while length of self.stack is greater than 0, and let's see, stack, the top of the stack is, let's use a tuple. So let's say the first element is less than or equal to price. And I'm just thinking about whether on these ones, whether we need less than or less than equal to, and this one I think we saw it somewhere that is less than or equal to. So actually, in this case, in theory, it doesn't matter, but maybe this way it's just a little bit easier to kind of merge them anyway. Because why not merge them, right? So then, yeah. So let's just one counter is equal to 1 for the price itself, because you have to count itself, and then we pop off. But before we pop off, I think stack actually returns it. But let's just do counter plus or equal to stack, the top of the stack. Oops. The second element pop off, and then at the end we push, a pen in this case, and it's just self.stack. We push back the price and then the counter. I think that allows us to process it. I think we forgot to return it. Okay, so we just return a counter, I think, in this case. That should be okay. Okay, let's give it a go. I guess we don't have a custom case yet, just because I'm a little bit lazy. Let's try it. Stack is, where am I? Oh, there we go. Okay, so this looks pretty good. In theory, and I recommend people just test this stuff in general with more things. This is a little bit annoying to test, so I'm just going to submit. But in theory, you should test, and in an interview, you should test. But some of it is I'm just a little bit confident on this one, and there shouldn't be that many edge cases except for like, I don't know, 1 element or something like that, or maybe even 0 element. But yeah, we got accepted, so that means, that we feel great. Again, this is linear time because for each element, at most we push and pop once. And yeah, and the space is linear space, obviously. But I hopefully, I did elaborate a little bit on my thought process, and yeah, I hope that this was helpful. Hit the like button, hit the subscribe button. I think the thing that these things comes up all the time on interviews and competitive programming, so definitely try for it. But yeah, I think the thing that I want to emphasize on problems like this, it's very easy to get into a mindset of like saying just, oh yeah, this is a monostack or a monoqueue, and this is why. But I think what I urge when looking at these problems just try to think about what happens when you add a number, what happens to the previous numbers, what are you asking? At here, as I was like 70, okay, actually we want the biggest, we want to get to the next number that's bigger than 70 in a streak that we ignore all the smaller numbers in between and something like that. 75, same thing. So yeah, so I think from that, you should be able to build the algorithm that way. And it so happens that the stack is monotonic, but like that would not have been a feature that I somehow reverse engineered. I was like, oh, look at this sequence. You just have to do, you just get the longest decreasing, or I don't know, right? Like that doesn't make sense to me. My process is, okay, we have all these sub problems kind of, not in the dynamic programming sense, but like you have a problem like, okay, here, what is the answer, right? And then we kind of look back that way. Is there a data structure that allows us to look from right to left one at a time, or more than, or quicker than one at a time, because one at a time would be n squared, right? Anyway, that's all I have for today. Let me know what you think. Hit the like button, hit the subscribe button, leave your questions, comments, feedback, and I will see y'all tomorrow. Bye bye.